To find the intervals of increase and decrease, we need to find the critical numbers of the first derivative. So to do that, we make both the numerator 20x equal to 0, which gives us x equals 0, and also the denominator equal to 0. And that gives us positive and negative 2, which, by the way, were restrictions in our domain. So they are not actually considered to be critical numbers, but restrictions of the domain. And so we still have them as endpoints of the intervals on which we are going to test in. So we have -2, 0, and 2. Now since the denominator of the first derivative is squared, the denominator will always come out as positive. So the only part of the first derivative that I need to test in would be 20x. So first I will be choosing my test points in each interval. From -infinity to -2, I'll be using -3. Here I'll be using -1, 1, and 3. So those are my test points. And then what I do is plug it into the first derivative, on which I will only be plugging in to 20x. So this comes out as negative, negative, positive, and positive. So now my conclusion would be decreasing, decreasing, increasing, and increasing. So now what I'm gonna do next is go back to my second derivative. And use now the second derivative to find concavity, intervals of concavity. Note that the numerator of the second derivative can never equal 0, since if you make 3x squared plus 4 equal to 0, you will only get imaginary numbers. So the only critical numbers that we'll get will be from the denominator, which will give us the points positive and -2. But then remember that positive and -2 are restrictions of our domain. So x cannot equal positive or -2. What that means is we won't be able to have any inflection points. So what we just need to do is test each interval for concavity, and the endpoints of our interval will only include -2 and 2, since 0 is not a critical number, or we didn't find any critical number for the second derivative. So let me choose my test points to be -3, I can use 0, and then 3. So I plug that into the second derivative. Now this 3x squared plus 4, any number that you plug into that will always come out as positive, and this will always be negative. So what I just need to plug in would be -20 over x squared minus 4 cubed. So if I plug in -3 here, this will be -20 over 9 minus 4 cubed, which will come out to be negative. If I plug in 0, this will be negative 4 cubed. That's negative by negative, so that comes out as positive. If I plug in 3, it will come out the same as for negative 3, so this will come out as negative. So we have from negative infinity to negative 2, we'll have the graph will be concave down. From negative 2 to 2, we have the graph of the function f would be concave up, and from 2 to infinity, the graph would be concave down. So now we need to bring together the intervals of increase and decrease with our intervals of concavity. Okay, note that the intervals of increase and decrease have endpoints of negative 2, 0, and 2, while the intervals of concavity only have endpoints of negative 2 and 2. So how do we bring them together? Since the intervals of increase and decrease have more intervals, we have 1, 2, 3, 4 intervals, while the concavity has only 1, 2, 3. We want to be able to bring them together by considering all the endpoints of the interval, of the one that has more intervals. So I'm going to use what we have for increasing and decreasing. We have from negative infinity to negative 2, I have the function will be decreasing, and then on the concavity it says from negative infinity to negative 2, we have concave